right, so this is going back to last unit. So the only difference, there's really nothing new besides what we're learning right now and what you learned last unit, except for signs. So when we did our right triangle trig, all of our cosines, sines, tangents, everything was a positive value. So when we're in a standard, when we draw our angles in standard form and they can be bigger than acute angles, you'll get some negative sine values or cosine values or tangent values. So that's really the only difference, but it shouldn't be too much different. So they're going to let theta be an angle in standard form. Here's your theta right here. That is that angle right here. So they're going to give you a point. They're going to give you an x and a y point that's on this terminal side of that angle. Notice that x and y, really they give you two sides of a triangle. So if you were to draw a triangle to the x-axis, make sure it's always uses that x-axis right there. So if you draw a triangle, you've got the x, the distance that you're going here, x, and you got the distance of y. And then they're calling this r, and we'll explain that more next time because we're going to draw some circles. So it will be a radius, but for right now, just know that that hypotenuse is what they're calling r. So remember from last unit as well, if you know two sides of a right triangle, if you know the x and the y, you can find the hypotenuse, or what they're calling r here using your Pythagorean theorem. So the r is the c, that's your hypotenuse. So we can just say that x squared plus y squared here is equal to r squared. So that's going to be your first step. You've got to find all three sides. I'll give you an x and a y. You've got to find the r. P.S. Remember, if you square a number, it'll be positive. Okay, so even if your x value is negative like it is here, that'll turn into a positive. So your r, or your hypotenuse, will always be a positive value. All right, so remember our SOHCAHTOA from last unit, our SOHCAHTOA. I'm going to just write it right up here. So when we were doing this, our sine here, remember our sine, S stands for the sine. So the sine of an angle, theta, is equal to the opposite over the hypotenuse. So when we are graphing this, instead of using this, the angle that they give us, we're always going to use the reference angle. So it will always be an acute angle. Remember, the reference angle that we just learned goes from that terminal side of our angle to the x-axis. So our theta really is going to be right here. So you're first going to want to label your triangle with opposites and hypotenuses and adjacents. So I'm just going to go across from that angle theta, call my y my opposite. Across from your right angle is your hypotenuse. That leaves this to be the adjacent side. All right, so the sine, which is the opposite over the hypotenuse, we're going to use our x's, our y's, and our r's. So the sine is just going to be y, that's my opposite, over h, which is the r right there. Okay, the cosine is your adjacent over your hypotenuse. So my adjacent is x over that hypotenuse, which is r. And then the tangent is your TOA, so opposite over adjacent. So my opposite is y over my adjacent, which is x. And then remember, we have what we call the reciprocal functions or reciprocal ratios, whichever. And they're just the reciprocal. You just flip the top to the bottom, bottom to the top. So the cosecant, the reciprocal of the sine. So that r is just going to be in the top over y. The secant is r over x, and the cotangent is x over y. All right, so now let's do this with an actual point. That was just kind of an example. I'm going to leave it here so I can still see those three things. But now we're going to use some numbers instead of our hypothetical x and y. They're going to give us a point. Our point is 5, negative 2. So we're going to go over 5. Let's do purple. So we're going to go x is 5 and y is negative 2. So here's our nice lovely point right here. Now, again, when you draw the triangle, you have to make sure that you're using the x-axis as one of your sides. That doesn't stand out. Let's do red. So we're going to use this x-axis as one of our sides, and then just draw down to that point, and then you're going to go from the origin here to that point there. Okay, and this is the terminal side. I don't know right now if it's a positive angle or a negative angle, but I'm going to use this as my theta. Okay, that reference angle, remember, goes from the terminal side to the x-axis. So there's theta. So you got two options here. You could either plug in these y's over r's and all that lovely stuff, or you could draw them out. I'm going to actually just write them out and say, okay, this, my x direction I knew was 5. Okay, they gave me that 5. This y is -2. Now, I know the distance is actually a +2, but I'm going to write that -2 there just because it will help me when I'm doing my signs of these. In this quadrant, there's a few of these trig functions that are negative. So we're going to leave that -2 right there. I am as well, and you don't have to do this, or you could do this, it doesn't matter, but I am going to also label this. So this is my opposite side here. This is my adjacent side. And then here's my right angle. So this guy over here is going to be my hypotenuse. Now notice we don't have a value for the hypotenuse. So that's where this lovely Pythagorean theorem is going to come in. First of all, you've got to find that value. So we're going to go ahead, and it doesn't matter. Remember, as long as this r right here is the hypotenuse, you'll always be given the x and the y. So you're always just solving for that r, but it doesn't matter which one is first. But let's go ahead and just write it like this. So our x is 5 squared plus y is -2 squared. Make sure that's in parentheses if you're doing it in a calculator. So 5 squared is 25. -2 times -2 is a +4. That will always be positive. Do not forget that. Okay, 25 plus 4 is 29. So 29 is equal to my r squared. R is not 29, r squared is. So remember to take the square root right there. So we could say that r is equal to the square root of 29. So we're going to have that square root of 29 right there is my hypotenuse. All right, now we've got our 3, our x and our y and our r. We can either just go plug them in according to what was here, or you could still use we lost it here, but you could still use your SOHCAHTOA if that's how you like to remember them, because you won't have this on a quiz. So I would suggest knowing that. Remember, your sine is your opposite over hypotenuse. So your opposite is a -2 over the hypotenuse, which is the square root of 29. And oh dear, look at this. We've got a radical in the denominator. So that's a no-no. We're going to change it, but we're going to leave it for right now. So just leave it. We'll come back to that in just a minute. Okay, let's get all of our values in. The cosine is your adjacent over your hypotenuse. So that is 5 is my adjacent over my hypotenuse, which is the square root of 29. That one's an auto too. We'll be back for it. My tangent is my opposite over adjacent. So my opposite, which is -2 over my adjacent, which is 5. That one's okay. You could circle that one. You're done with that one. Okay, no radical in the denominator. Now remember, these reciprocal functions, you're just going to flip. So this one just goes to square root of 29 all over -2. I like to write my negatives in the top, but if you put it in the bottom, that's fine. No radicals in the denominator, so that one's done. You can circle that one. Okay, same thing happens here. Flip it. So you got the square root of 29 in the top over 5. No radical in the bottom. Circle it. You're done. Cotangent is going to be 5 in the top over -2. Again, I like my negatives just to be in the top. It doesn't matter where they are as long as it doesn't just disappear. Okay. And then last thing you want to do is fix those lovely radicals in the bottom. So remember from last unit, all you have to do is multiply by that radical over itself. So anything divided by itself is 1, but this will just end up to be -2 square roots of 29 in the top. And then basically what you're doing is you're squaring it and then square rooting it. So it just undoes it. So it's just going to be a plain 29 right there. Okay. Same thing here, just multiply. I'm going to multiply by the square root of 29 over the square root of 29. And I have 5 square roots of 29, all divided by 29. And we're done. All right, that's a lesson. Good luck on the homework.